Ew. All right, we are going to be working the lecture 2.1a, part 2, solutions for page 99, 7 through 19 odd. So number 7 is f of x is equal to negative 5x, and we want to find f prime of x. We're trying to find the derivative. And here's our formal definition of the derivative equation. So we're going to take the limit as delta x approaches 0 of f of x plus delta x. Well, that's going to be negative 5 times x plus delta x. All right, so everywhere there's an x, you put an x plus delta x, minus f of x, which is minus 5x. This is a pretty short one, right? Over delta x. So that's equal to the limit as delta x approaches 0. Distribute the negative 5, so it'd be negative 5x minus 5 delta x. And then the minus 5x would make this a plus. Okay, so minus 5x. So maybe it's easier to put that in parentheses. So that's plus 5x over delta x. And that's equal to the limit as delta x approaches 0. The negative 5x and the positive 5x cancel out. And you just have negative 5 delta x over delta x. The delta x's cancel as long as delta x does not equal 0. And you have the limit as delta x approaches 0 of just negative 5. There's no delta x to plug into, so that's just equal to the constant negative 5. So the derivative f prime of x is just equal to negative 5. We don't have an x in it. Okay? Number 9. We have f of x is equal to 2x squared plus x minus 1. Okay, we're going to use this equation. So we're going to take the limit as delta x approaches 0 of f of x plus delta x. Well, what is that? Everywhere there's an x, put in x plus delta x. So that's going to be 2 times x plus delta x, all squared. We have to square it because the x is squared. Plus x plus delta x, because we're at this part, minus 1, and then minus, let's put a parenthesis, f of x. That's 2x squared plus x minus 1. All over delta x. Now, expanding the x plus delta x, that's just foiling that out, and we've done enough of these, you've probably learned the formula, really. You don't have to foil it out. But it's 2 times x squared plus 2x delta x plus delta x, all squared, plus x plus delta x minus 1, and then distribute this negative sign, minus 2x squared minus x plus 1, all over delta x. And distributing that 2, we'd have 2x squared plus 4x delta x plus 2 delta x all squared plus x plus delta x minus 1 minus 2x squared minus x plus 1. Listen, don't skip this part here. You will make a mistake if you do. Go ahead and write all that out. Otherwise, you'll forget to multiply 2 by 2 and you won't have a 4 there. So now we can eliminate. We end up eliminating all the non-delta x terms, don't we? Positive x, negative 1, positive 1. And we have the limit as delta x approaches 0 of 4x delta x plus 2 times delta x, all squared, and all that's left is plus delta x. Everything else has been eliminated. What are we going to do to the top? You tell me. Going to factor out a delta x. So 4x plus 2 delta x. What happens if you factor a delta x out of a delta x? You get a 1. We can cross out that delta x. That was the troublemaker. As long as delta x does not equal 0. We have the limit as delta x approaches 0 of 4x plus 2 delta x plus 1. We plug in that 0 in right there. And what's left is 4x plus 1. And that is equal to, that is our equation for the derivative, f prime of x. Now I'm going to show you in a couple of days how you can get that answer in about 2 seconds. All right, but we got to learn how to do it the formal way first, and you will have to do one of these on the test. Okay, now the problems are really going to get tedious for a while, and then the last couple aren't too bad. Okay, for the next 3 problems, I'll probably just put 1 on the page here. So number 11, we have f of x is equal to x cubed minus 12x squared. Okay, f prime of x is equal to the limit as delta x approaches 0. F of x plus delta x. Okay, everywhere there's an x, we put x plus delta x, but we have to cube it. Minus 12 times x plus delta x, but we have to square it. And then we're going to subtract out f of x, which is just x cubed minus 12x squared. All over delta x. Now I gave you the formula for expanding the cube, so that was x cubed plus 3x squared delta x plus 3x delta x all squared plus delta x all cubed minus 12, and then we FOIL that one out, so that's x squared plus 2x delta x plus delta x all squared. Wow. Minus x cubed plus 12x squared all over delta x. All right, these aren't for the faint of heart. A lot of the math students I've had that aren't really into math get mad during this part. Okay, don't let that be you. Tough it out. It's not so bad. Okay, so we've got x cubed plus 3x squared delta x plus 3x delta x all squared plus delta x all cubed. Distribute the 12, so minus 12x squared minus 24x delta x minus 12 delta x all squared minus x cubed plus 12x squared. All right, running out of space there. Over delta x. Okay, we can eliminate some things here. I can eliminate the x cubed and the minus x cubed. We can eliminate the minus x 12x squared and the plus 12x squared. So what's left? 3x squared delta x plus 3x delta x all squared plus delta x all cubed. That's a delta. It's a triangle, sorry. Minus 24x delta x minus 12 delta x all squared over delta x. Now I see I have made a mistake with this problem because it's not x squared, it's just x. So that actually makes this problem a whole lot easier. So I want to apologize if you watched this so far, but that's not squared. So I'm going to have to rework this, but I'm not going to stop the video. So I am going to just start over from right here. All right, so this was expanding a cube, so that's x cubed plus 3x squared delta x plus 3x delta x all squared plus delta x all cubed minus 12x minus 12 delta x minus x cubed plus 12x squared. All right, so let's make sure I've got all that right. Over delta x. Okay, so all right, yeah, double checking here. So x cubes cancel. So actually squaring it before made it a whole lot harder, didn't it? And the 12, let's see, 12x, and then this would just be 12x also. Okay, so f of x is x cubed minus 12x, so that would make that cancel and that cancel. And so what's left is 3x squared delta x plus 3x delta x all squared plus delta x cubed minus 12 delta x, and that's it, over delta x. Okay, so we can factor out a delta x, so that's going to be 3x squared, and then we would have a plus 3x delta x plus delta x all squared minus 12 over delta x. We can cross the delta x out as long as delta x does not equal 0. We have the limit as delta x approaches 0 of 3x squared plus 3x delta x plus delta x all squared minus 12. All right, and when we plug zeros into those delta x's there, you're left with 3x squared minus 12. All right, so I'm so sorry for writing the problem down wrong in the beginning. That caused me to have to write a whole lot more, and I also had this one written down wrong. But I believe we've worked it out here, and that's how you do it. So I'll try to do a little better on the next one. Sorry about that. Okay, number 13. We have f of x is equal to 1 over x minus 1. So f prime of x is going to be the limit as delta x approaches 0 of 1 over, everywhere there's an x, you put x plus delta x, so minus 1. So f of x plus delta x would be this, minus f of x over delta x. Now this is a compound fraction, and we're going to put those together. All right, we're just going to subtract these two. And remember that the shortcut is to multiply the denominators together. So I'm going to put parentheses around them. Delta x minus 1 times x minus 1 And I'm going to bring the x minus 1 up here. And put the second part in parentheses. X plus delta x minus 1, put it up on the top right. All over delta x. Now I can move this up a level, that delta x, and I'm going to clean up the numerator. So I've got x in the numerator, x minus 1 minus x, I'm distributing this negative sign, minus delta x plus 1 over delta x times x plus delta x minus 1 times x minus 1. As delta x approaches 0, okay, here we've got an x and a negative x, a negative 1 and a positive 1. So on top, all I've got left is negative delta x over delta x times x plus delta x minus 1 times x minus 1. Now I can cross out, as long as the delta x does not equal 0. We're almost done with this one. It's going to be negative 1 left on top, x plus delta x minus 1 times x minus 1. Now we can plug that 0 in here, and you're left with negative 1 over x minus 1 times x minus 1. And a better way to write that is negative 1 over x minus 1 all squared. And that is equal to your derivative. All right. So that one actually didn't take up nearly as much space as number 11. Number 15, I still don't know that it's going to take up as much space as number 11, but we'll see. All right, number 15, and this is the last super tedious one. We have f of x is equal to root x minus 4. So f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x. That would be the square root of x plus delta x minus 4 minus the square root of x minus 4 all over delta x. Now let's double check that. X, we're going to replace that with x plus delta x, and then minus 4, and then minus f of x, so minus that. Now, I need to get rid of, I gave you a hint to rationalize this, so we need to multiply by a clever version of 1. So that'd be x plus delta x. So anytime you see radicals, you think of maybe doing this, plus the square root of x minus 4 over the square root of x plus delta x minus 4 plus the square root of x minus 4. You have to do the top and the bottom. That's just 1, isn't it? It's just a fancy version of 1. All right, and now we can FOIL the top. Well, if you multiply the radical times the radical lifts. All right, so we have x plus delta x minus 4. The middle term is positive. The outer term is the middle term is negative. The outer term is positive. So that whole section cancels. That times that, and then plus that times that. It all cancels. That was the point. And then minus x minus 4. Because root x minus 4 times root x minus 4 is x minus 4. And then there's a negative sign there. All over delta x. All right, so we have x plus delta x minus 4 minus x plus 4 all over delta x. Now the bottom, I'm sorry, the bottom I forgot to multiply by this. So root x plus delta x minus 4 plus root x minus 4. Can't forget that. Okay, so now we have the limit as delta x approaches 0. The top, the x's cancel, the 4's cancel, and all you're going to have on the top is delta x. On the bottom, you've got a delta x, and you have the square root of x plus delta x minus 4 plus delta x minus 4. Now the delta x's cancel as long as delta x does not equal 0. And you have the limit as delta x approaches 0 of 1 over the square root of x plus delta x minus 4 plus the square root of x minus 4. Now we can plug that 0 in right there, and you have f prime of x is equal to 1 over the square root of x minus 4 plus the square root of x minus 4. All right, now a better way to write that is 1 over 2 times the square root of x minus 4, because the square root of x minus 4 plus the square root of x minus 4 is just 2 times that. And again, I'm going to show you a shortcut in a few days of how much faster, a way to do this, all of this a lot faster. Okay. Okay, 17 and 19 are a little bit shorter. We want to find the equation of the tangent line. So you do need to remember y minus y1 is equal to the slope times x minus x1. Okay, that's our tangent line equation. So 17, we have f of x is equal to x squared plus 1 at the point 2, 5. Okay, f prime of x is equal to the limit as delta x approaches 0 of x plus delta x all squared plus 1. That's f of x plus delta x. Remember, we're just taking that x and changing it to x plus delta x. Minus x squared plus 1 over delta x. Okay, expand that x plus delta x all squared, and you're going to get x squared plus 2x delta x plus delta x all squared plus 1 minus x squared minus 1 over delta x. Alright, so the x squared, negative x squared, 1, negative 1, and you've got the limit as delta x approaches 0 of 2x delta x plus delta x all squared over delta x. We're going to factor a delta x out of the top. So that'd leave us 2x plus delta x as long as delta x does not equal 0. We can cancel those out. So we have the limit as delta x approaches 0 of 2x plus delta x. We're going to plug that 0 into delta x, and that's just going to be 2x. That's the equation for the derivative. You'll be able to do that in about half a second in a few days. Okay, that's f prime of x. So the slope is going to be, you plug in the x value into this equation. So 2 times 2, X value is 2. So that's 4. So that is our slope. So we have y minus 5, that's y1 is 5, is equal to 4 times x minus 2. That's our, so this is y1, this is x1, this is m. Right? So that's the equation of the tangent line. Number 17. Y minus 5 is equal to 4 times x minus 2. For my purposes, you do not have to change that into slope-intercept form. But you can. Just to remind you, that's y is equal to mx plus b. If you decide to do that, you just solve for y. So y is equal to 5 plus 4x minus 8. So y is equal to 4x minus 3. So your slope is 4 and your y-intercept is negative 3 on this if you needed to do that. We did a lot of that in Algebra 2 and Pre-Cal. Okay, goodness. Last one coming up. Number 19, we have f of x is equal to x cubed. So f prime of x is equal to f of x plus delta x. That's x plus delta x, all cubed. So I'm going to have to expand that cube. Minus x cubed over delta x. And it's the limit as delta x approaches 0. So that's going to be the limit as delta x approaches 0. We have our cube expansion. It's going to be x cubed plus 3x squared delta x plus 3x delta x all squared plus delta x all cubed minus x cubed. I somehow managed to get it in there over delta x. So equals the limit as delta x approaches 0 of the x cubes cancel, and we have 3x squared delta x plus 3x delta x all squared plus delta x all cubed over delta x. Let's factor out a delta x out of the top. So we have delta x and we have 3x squared plus 3x delta x plus delta x all squared over delta x. We can cancel that as long as delta x does not equal 0. And we are near the end. Delta x approaches 0 of 3x squared plus 3x delta x plus delta x all squared. We plug a 0 in there and there. And what's left is just 3x squared, and that's equal to f prime of x. That's the equation of the derivative, but we have to get the equation of the tangent line, so we have to do a little more work. Our slope is going to be, what are we going to plug in? Now, looking back, it's at the point 2, 8. So we're going to plug in 2. So that'd be 3 times 2 squared. So we're just going to plug in a 2 for x there. So that's 12. Our slope is 12. So we have y minus 8 is equal to 12, the slope, times x minus 2. That is perfectly fine for me. If you want to change it to slope-intercept, just push that positive 8 over to the right and combine like terms and clean it up. And you would have y is equal to 12x minus 16 if you do that work. But I don't need that. This is fine. Okay, that does it for today's homework. I am sorry about number 11, where it took me a while to catch my mistake. I wrote the problem down wrong, so that made that answer longer than it should have been. So sorry about that, but we'll move on and talk to you next lecture.